Okay, and I made in Shovie, I made you guys a folder to tell me if you're retaking a test, and if so, which one. Instead of passing around a sheet, which everybody then could see what test somebody's retaking, which is private issue, you can just type in here and tell me what test you're retaking. Okay. Test, retake. Which test do you want to retake? I'm thinking Tuesday, Wednesday, or Thursday afternoon next week. Let me know what your schedule is like. We're going to do that. Okay. So I've got. We'll work it out.
Could you just post your hours available?
Sure. Sure, I can do that.
That'd be more helpful, I think.
Okay, I'll post my hours available, and yeah, it'll probably be like Wednesday and Thursday, right? Don't you think? But okay, I'll post what hours. I've got my my worker that can help watch you while I'm advising engineering students. So you'll be in the copy room upstairs. So, all right. So just let me know what test you're retaking, and I'll post the hours in there. Okay. So this is a totally different section now. This is polar, but we use the concept. This is polar coordinates. So that's why I passed out this paper. Did everybody get one of these things? We're going to be drawing. We're going to be using polar coordinates. We're going to be converting back and forth to rectangular. So it's different, but we have to use the concept we've learned. So the polar axis, you've got to define the polar axis, is a ray that extends to the right. It's a horizontal ray. And its endpoint is called the pole. And the book is good, but here's so if we start here, this is our polar axis. This is called the pole in the center. Its endpoint is called the pole. It's a ray that extends to the right. So it's got an arrow on the right. Its endpoint is called the pole. So this is the polar axis, and this is the pole. Okay. Points in a polar coordinate system are represented by the ordered pair, capital P equals R, comma, theta. So instead of x, comma, y, we have r, comma, theta. These are the polar coordinates of the point. R is a directed distance from the pole to P, is the point P. Theta is the angle from the polar axis to the line segment from the pole P. So we're going to practice, and there's examples in the book too. We're going to plot the following polar coordinates on the paper I gave you. So you always start with your angle. Okay, so we're going to do an angle in standard position, 315 degrees is over here. and R is 3. So we're going to end up being here. This is 350 degrees. So there's the point. That's a point. I drew the ray for 315 degrees, but that's the point. I've just plotted the point.
What does the 3 correspond to? How outward it is?
1, 2, 3.
Oh, okay. Cool.
Yeah, the radius. Yeah. So this is a 1, 2, 3. Right, good question. Okay, so we go with the angle, and then we go the whatever the radius is, whatever R is. This was 3, so that's the point. 315. Okay, the next one we want to plot the point -2 pi. So I'm going to do pi first. Starting from here, pi that's a straight angle. That's pi, but so going this direction would be +1, +2, but it said -2. So we got to go this way. -1, -2. So the point -2 pi is here.
So all we do is extend the line through the origin.
So we figure out, we're figuring out our theta is pi, and then we have to start at the pole, and since R is -2, we have to go the other way.
So do we always put that line going to the right first? That's just.
We always do the angle first. We're going to always do the angle first. So here, this angle was 315. We did the angle first, and then we start at the pole, and we count our R. Okay? And the last example is what? Well, that's not the last thing. So -1, -pi over 2. So we're going to go to, let's just, -pi over 2 is, so this is just here. That's that angle, but now we start at the pole and it said -1. So that's the point. -1, -pi over 2. Can you see that? Okay. We went the angle first, and then we started our pole and count out the R. Because the R was negative, we have to go this way. Anytime R is negative, we go opposite the way the angles go. So you can see in this coordinate system, there's many ways we could denote this point. This point would be easier to be denoted as pi over 2, 1 pi over 2. You know, 1 comma pi over 2 is an easier way to represent that. But this is that's what happens when you have negatives. Okay? And then there's one more example, I think. 5 pi over 4. So, pi over 4 is 45 degrees. So And then 5 is 1, 2, 3, 4, 5. So this is 5 pi over 4. Okay, so that's how you draw, that's how you find points on the polar coordinate system. And you'll have this piece of paper. So, and this is, I have this piece of paper posted online. I think I even have it in your homework for this, so, okay. But, any questions? So, we start with the angle, and then what do? We go to the pole, or in the rectangular coordinate system, that's our origin. And then we count R. If it's a negative R, we're going to go in the negative direction, opposite that angle. Okay? All right, if n is any integer, then the point r theta can be represented as r theta plus 2n pi. Or r theta can be represented as negative r theta plus pi plus 2n pi. So find another representation for 5 pi over 4. Okay, so we're going to just find 3 representations for this. When we want r to be positive, but we want theta to be between 2 pi and 4 pi. So if we're keeping theta positive, it would be 5 pi over 4 plus 2 pi. Well, that's 8 pi over 4. So that's 9 pi over 4. We just added 2 pi to pi over 4 to get it between 2 pi and r to be negative. Now we want to get it as minus
5 and we want theta to be between 0 and 2 pi. So all we have to do is take pi over 4 and add pi to it. And that will be 4 pi over 4, 5 pi over 4. You could sketch it if you want. I drew a little picture on the filled-in notes, I think, of all these. Okay. Is that making sense? So we were at pi over 4, pi over 4. We could also get there by going around like that. So that's not 9 pi over 4. We could also get there by doing 5 pi over 4. And then starting here and going in the negative direction. And now we want r to be positive, and we want to use a negative angle. So what's that negative angle? That would be
minus 7 pi over 4, or we take 5 and we subtract 2 pi. Okay? Yeah.
So why does it say, like, above it says negative r theta plus pi plus 2 n pi? If
Oh,
you're just gonna add pi.
okay. Well, this is whenever you make, when r goes from positive to negative, you have to add an extra pi in there. But here we kept r positive, so that's why I added 2 pi,
So
or subtracted 2 pi.
why did we only have to add pi and not add pi, like,
Okay,
2 pi?
because I was letting n be 0, and because we're going from positive 5 to negative 5, so when we're going, this is when we're keeping r positive, or keep r the same sign. You just add 2n pi to the angle, where n can be any integer. But if you change the sign of r, it's an extra, it's a difference of pi there.
So you don't have to add,
So that's why you add pi plus 2n pi. And the reason I only added pi is that would keep me between 0 and 2 pi. If they wanted me to go between 2 pi and 4 pi, say r is negative, and have 0, no, not 0, 2 pi to 4 pi, then I would do minus 5 pi over 4 plus pi plus 2 pi. Okay? Does that answer your question?
yeah.
Okay. So it's because we went from positive to negative with r. I'm glad you're asking these questions. Good question. So that was an extra example. I didn't finish it, but that'd be 3 pi is 12 pi over 4 plus 1 pi, 13 pi over 4. That would have been 13 pi over 4. Okay? Oh, where did it go? Ah! Oh. The whole screen disappeared. The cursor was somewhere in the bottom. Okay. Oh, some people are writing that example down. So, okay. Jacob Brick. Okay. Did you finish? Oh, Katie, are you still writing? Okay. All right, so here's what's our relationship between polar and rectangle coordinates. this is point P up here. We have P is represented by R, comma, theta. And it's X, comma, Y. So what would cosine of theta will be X over R. So if you're solving for X, you're going to want to multiply through by R. You get R cosine theta. This is the relationship. Sine theta is opposite over hypotenuse. Y over R. If you're solving for Y, you multiply through by R, you get R sine theta. And X squared, this is a right triangle, so X squared plus Y squared equals R squared. And tangent of theta will be opposite over adjacent, Y over X. So here's how you convert from polar to rectangular coordinates. You use X equals R cosine theta, and Y equals R sine theta. You use those formulas. So to find the rectangular coordinates of the point with the following polar coordinates. So we've got R equals 3 and theta equals pi. So we're going to find X is R cosine theta. X is going to be 3 times cosine of pi. Pi, 1, 2, 3. Here's our point. Is what's cosine of pi?
Is
It's
-1, right? Three times -1. So X is -3. Right. Okay, Y, and that makes sense. This will be at -3. Y better be 0. All right. Y is R sine theta. 3 times sine of pi. Sine of pi is 0.
Whenever I type that first one in, I'm not getting a negative.
When you typed in cosine of pi,
Yeah.
you have your mode set to radians. Just set your mode back to radians. 'Cause you
Okay,
won't-
now I get it.
Now you get it. Okay, you had the mode wrong, because we were in degree mode until this section. So, gotta check that mode. So, yeah, and we know what the picture looked like, so we should be getting this. So, all right, converting -10, which is R, this is theta. So, X equals R cosine theta, -10 cosine of pi over 6. So the exact value, cosine of pi over 6, if you look at your unit circle, that is square root of 3 over 2. So we get -5 square root of 3. For an exact value, Y equals R sine theta -10 sine of pi over 6. Sine of pi over 6 is a half. Is -5. So our rectangular coordinates are minus 5 square root of 3 minus 5. That's x comma y. For that example. And if you put that in your calculator, you would get that it's approximately minus 8.66 minus 5. And so you can convert back the other way, but when we convert the other way, there's many representations. So we are going to choose a representation. When we convert from rectangular to polar, there's many of them. So we're going to choose where R is positive and theta is the smallest positive angle. With its terminal side passing through xy. And we can check with our calculator. We can check these with our calculator. So this is, we're choosing this representation. But we will plot the point xy. We will find R using the square root of x squared plus y squared. And find theta with tangent theta equals y over x. So we're going to use inverse tangent. And so that's how you find that. I also wrote down there's some calculator commands. You can go from rectangular to polar. From rectangular to polar. We're finding. We'll go over that next time. We'll go over how to use the calculator. You can show me how to use the calculator. But so we could stop there, or I could finish this last example. I know I started talking. Let's just do this rectangular. Let's convert this. How do we convert 1 and then square root of 3, negative square root of 3? We draw the picture, and here's our point. Find the polar coordinate. So R is going to be the square root of x squared plus y squared. X, this is x and y. So that's the square root of 1 squared plus negative square root of 3 squared. That's the square root of 1 plus 3 is the square root of 4, which is 2. Tangent theta equals x over y over x, which is negative square root of 3 over 1. And the angle whose tangent inverse is negative square root of 3 is negative pi over 3. So for the exact answer, but we want a positive angle. We want, we decided we're going to choose a positive angle between 0 and 2 pi. So minus pi over 3 is the same as 5 pi over 3. We're going to take 2 pi minus pi over 3, 5 pi over 3. So the coordinates are 2, 5 pi over 3. We're choosing R to be positive, and we're choosing the smallest angle between 0 and 2 pi, positive. Okay, we'll start there next time. Thank you guys. See you Thursday.